A sample of size 1 is taken from a Poisson distribution with mean mu. Now, typically the Poisson distribution is specified in terms of a rate parameter lambda, okay? But in this case, what we're going to do is look at it in terms of the mean, which is also the rate parameter. So essentially, in this case, the rate parameter is the mean and the mean is the rate parameter. So in this particular video, I'm going to use mu instead of lambda, which is what one would normally do. Okay, so let the null hypothesis be that mu is equal to 1, and let the alternative hypothesis be that the mu is equal to 2. A test rejects the null hypothesis if our observation x is greater than 3. Okay, calculate the probability of type 1 error of the test, and then calculate the power of the test. Okay, so the probability of type 1 error is the probability of rejecting the null hypothesis given that it is true. Okay, so in this case, it's probability of x greater than 3 given that mu is equal to 1. Okay, or lambda is equal to 1 also. So, which is the equivalent. Okay, just be clear about that. Now, so this is the probability density function of the Poisson distribution. Just as a quick remark, that is actually k factorial down there. So this typesetter has trouble with factorials. Okay, so essentially what we have to do here is calculate this here, probability of x greater than 3. Okay, the simplest way to do it is actually compute the probability of x less than or equal to 3 and then get the complement of that. Okay, so what we're going to do is calculate the probability of x less than or equal to 3 given that mu equals lambda equals 1. Okay, so e to the minus mu, and again it's specified in terms of mu here, but equivalently that is e to the minus lambda to the power of k over k factorial. Okay, and essentially what we're going to do here is calculate it for k equals 0, 1, 2, 3, and so 1, 2, and 3. Okay, now because e to the minus 1 is common in each case, what we're going to do there is just actually focus on this bit here for each of the 4 cases. 1 to the power of 0 over 0 factorial, that's 1. 1 to the power of 1 over 1, that's also 1. 1 squared over 2 factorial, that's 1 over 2. And 1 to the power of 3 over 3 factorial is 1 over 6. E to the power of minus 1, e to the minus 1 is 0.36787. You don't have to go to so many decimal places as I do. I just sort of keep it, so it's just I actually go more accurate, so you don't have to, but you're able to track how accurate you are or how close you got. Okay, in a real life exam situation, 4 decimal places is probably more than enough. But I'll just go a little bit extra accurate there just to make, just so you know how close you are to the real thing. So we add all those up, 1 plus 1 plus a half plus 1 over 6. That gives us 0.36787 times 2.6666. Okay, and when we add that all up or multiply that out, we get 0.98101. Okay. Now the answer we're looking for is, this is the power of not the power of the test, this is the probability of type 1 error. So this is the probability of x greater than 3 given that mu is equal to 1. So that's the complement of what we've just calculated there. That is 1 minus 0. Sorry, I'll just go there, do that again. 1 minus 0.98101. And that works out to be 0.01899, just approximately 2% really. Okay, 1.89%. Okay, that's the probability of a type 1 error. Okay, now the power of the test is 1 minus the probability of a type 2 error. Okay, and that is rejecting the null hypothesis. This is type 2 error, is the probability of rejecting the null hypothesis when it is false. Okay, so it's the probability of the x. So when it is false, h0 is false, that means that we assume that h1 is true. Okay, so that's essentially what we have to do, compute this here first off. Okay, and then find the complement of that. Now we're doing the same sort of calculation again. Just in this case, we're dealing with e to the minus 2. Okay. And what we're going to do here is calculate 2 to the power of 0 over 0 factorial plus 2 to the power of 1 over 1 factorial plus 2 squared over 2 factorial plus 2 to the power of 3 over 3 factorial. So that should be 3 factorial there. Okay. E to the minus 2, that gives us 0.1353. 1 plus 2 plus 2 plus 8 over 6, that gives us 0.1353 times 6.3333. Okay, working that out, we should get 0.85711. Okay, and the answer is essentially the complement of that. So essentially 1 minus that, and that is 0.14289, approximately 14%, 14.3% if you want to be correct or close enough. Okay, so just to be clear about something, I go to a lot of decimal places here. You don't really need to do that in real life. It's just to sort of be as accurate as I can, so so that you can benchmark about how well you're doing. That's all. All right, we'll leave it there.